All right, welcome. Have you ever had that feeling where you knew you had the right answer, but you just didn't get all the marks? Well, today, we're going to put an end to that. We are going to take an official AQA GCSE Chemistry mark scheme, pull it apart, and figure out exactly what the examiners are looking for. Let's get into it.
It really all boils down to this question, doesn't it? You can know your science back to front, but honestly, that's only half the job. To scoop up every single mark available, you have to know the rules of the game. And that mark scheme? That's your rulebook.
So here's our plan. We're going to laser focus on just one AQA question today. First, we'll crack open the question itself. Then we'll dig into a data task and a calculation. We'll even look at a different way to get to the right answer, before we wrap it all up and get inside the examiner's mindset.
Okay, let's jump right in. Our focus today is question 06 from an AQA paper, all about rates of reaction. We're going to treat the official mark scheme like it's the ultimate blueprint for getting a perfect score.
And this is absolutely crucial. Our goal here isn't just about finding the correct answers. No, we want to get inside the head of the person with the red pen. We want to understand why some words get you the marks and others don't. This is how you level up.
Right, let's zoom in on the first part we're looking at, question 06.4. This one's a 3-mark data interpretation task. So your mission is simple. Look at the data and make 3 separate correct points about what it's showing you.
Now this is where it gets really interesting. Look at this. The mark scheme actually lists 4 possible points you could make, but, and this is key, you only need to give any 3 of them to get full marks. That gives you a bit of breathing room, which is great.
So let's take a closer look at that first point. Using a phrase like directly proportional, that's perfect scientific language, right? But check out the extra info on the mark scheme. It says they'll also allow collected at a constant or steady rate. That's a huge insight. It tells you they're looking for the right concept, even if your wording isn't a carbon copy of theirs.
And this one shows that flexibility even more clearly. For point number 3, the mark scheme says to allow any value from 6 to 8 minutes. So what does that mean? It means if you wrote up to 7 minutes, you'd still get the mark. The important thing is showing you get the trend, not just naming the exact final second.
So what's the big takeaway from all this? Well, it's precision. It really matters. Phrases like increasing rate and directly proportional are the keywords that unlock those marks. You've got to be specific and use the language of science.
Okay, let's switch gears and tackle the calculation in question 06.6. This is another 3-marker, and for these, showing your work is everything. We're going to break it down step by step.
So here's the most direct route to the answer. First up, you've got to convert the volume. So you take 6.6 cubic centimeters and divide by 1,000 to get cubic decimeters. Boom, that's your first mark. Step 2, you use the formula to find the moles, so you divide that new volume by 24. That's mark number 2. And finally, just state the correct answer, 2.75 times 10 to the power of minus 4, and that third mark is all yours. Nice and simple. But hang on, this next bit is maybe the most important thing to know about calculations. Look at this guidance from the mark scheme. It's called error carried forward. It basically means if you mess up step 1, but then you use that wrong number correctly in step 2, you can still get the mark for step 2. This is a total game changer. It means you should never ever give up on a calculation if you think you've made a mistake. And just when you thought we were done with that calculation, the mark scheme pulls back the curtain and reveals another secret. There's often more than one right way to get to the answer. So check this out. Instead of converting the gas volume at the start, you could convert the molar volume from cubic decimeters into cubic centimeters. Then you can just divide the original 6.6 by 24,000. It's a completely different method, but it's 100% mathematically correct.
And what do you know? You end up with the exact same answer. Examiners are trained to spot different valid methods. So the moral of the story is, show you're working, show it clearly, and no matter which path you take, you'll get the credit. So, after this deep dive into just one single question, what have we actually learned about how examiners think? What are the big rules we can take away and use for every other question we ever face? Let's sum it all up. First, you've got to use those precise keywords. Second, always show your full working in calculations. Third, remember there's often more than one way to get to the right answer. Fourth, look out for those little words like allow that show you where there's flexibility. And last but not least, never forget that error carried forward rule. A little mistake doesn't have to be a total disaster. These are the real keys to getting those top marks.
So there you have it. We've just given you the blueprint for how to deconstruct any exam question and figure out what the examiner really wants.
The power is literally in your hands now. So the only question left is, which topic, which question are you going to take apart and master next?